Well, this video is of the R4 representation, which stresses the role of the sources and the targets for um, chromosome 1, but with respect to the one-shot connectrons. So let's knock out first the sources, the C1, C2s, and this shows how many of them there are in different places, how many connectrons are formed from the transcription events in the place around the spiral. As before, you can just look at a very small portion of the genome if you want, and so you see just the events in this particular region. So this is each 1/10 of the total length of chromosome 1. I'll put everything on. And so then these are the one-shot connectrons. And this is the spiral that shows the complete space that we're working about. So let's turn on the one-shot connectrons. This is similar to what we've seen before. And then this number 1 here shows this. But then the feature of this graphic is that there are a series of, perhaps if I go to the center you'll see it a bit better, a series of loops that are formed by other chromosomes. And so this graphic shows you how the other chromosomes send connectrons to chromosome 1. We of course can turn on all of these things here altogether, and so you see that there is quite a bit of interaction between the other chromosomes and chromosome 1. And so there are huge regions where a given chromosome can have an effect on chromosome 1. Again, we can, as always, pick a particular place and zoom up and see the microstructure. So, for example, here you can see the microstructure of how chromosome 6 is causing interactions, causing loops on chromosome 1. Each of these graphics has a different demeanor, and the purpose in doing these was just to explore what these different representations could do. So you see, you can see this is chromosome 8 sending RNAs, sources, connectron sources, from transcription events on chromosome 8 to chromosome 1 to form loops in these different places, and a variety of different loops. So this graphic, like the others, has a particular idea behind it, and the idea that I had was to try to understand, first of all, where the connectrons are and what were causing them, because you can't get everything in one representation. And so later on we'll talk about the genomic wall, which is an idea for having 25 displays, each one looking pretty much like this, with different representations on them. And so you have to understand that the connectron structure of a genome is very complex, and that there are events occurring on many different chromosomes, and these events are interacting with each other. So I mean, this representation very nicely shows that that the transcription events on chromosome 12 in this case are could cause loops to form on chromosome 1. And so each representation has a different property or set of properties, and each chromosome has a different set of loops and sources, etc., etc. So, so you can't hope to understand the dynamics of how a genome's expression of gene coding and non-coding events are orchestrated unless you have both the variety and complexity of representations and even the number of displays to be able to see what events are happening on a given chromosome at a given time. And then, of course, the transmission of events between chromosomes, and I'll show you that in a little while.